Welcome to another episode of the Part 145 EASA training from Phoenix Way Academy. Hi, I'm Sarah.
Hi, and I'm Sam.
Well, in this deep dive, we will continue the topic of 145.A.50 certification of maintenance. Our mission today is to really unpack the complexities of AMC 2145.A.50.D.
That's the acceptable means of compliance number 2.
Yes. We're going to focus on how various component scenarios impact the issuance of an EASA Form 1, aiming to give you, our listener, a really clear, thorough understanding.
And that understanding is absolutely crucial, isn't it?
It really is.
Because it directly impacts airworthiness, compliance, and ultimately, safe operations and aviation maintenance. Getting these details right is vital.
Okay, let's jump right in then. Let's unpack the fundamental concept here in AMC 2145.A.50.D,
Okay.
which deals with how maintenance is certified.
Right. So the core principle, it's actually pretty straightforward to start with. A component which has been maintained off the aircraft needs the issuance of a certificate of release to service for such maintenance.
Okay, so one for the maintenance itself?
Exactly. And another certificate of release to service in regard to being installed properly on the aircraft when such action occurs.
So two releases.
2 releases. One certifies the work done on the component, like an overhaul, and the second certifies the work done to install that component correctly back onto the aircraft. It's like a dual check system for safety and compliance.
Can you give us an example?
Sure. Imagine an engine part, maybe a fuel pump, gets sent out to a specialized engine shop for overhaul.
Okay.
It gets its first release, an EASA Form 1,
Right.
maybe from that shop, certifying the overhaul.
Right.
Then, when it comes back to the hangar and a mechanic installs it onto an engine on the aircraft, that installing mechanic has to issue a second release.
Okay.
That second one covers the installation work specifically.
So that's the general rule. 2 releases for off-aircraft maintenance and then the installation. But you mentioned an interesting clarification about internal use.
Yes, absolutely. The guidance offers some flexibility here. It says, when an organization maintains a component for use by the same organization, an EASA Form 1 may not be necessary.
May not be necessary.
Correct. Depending upon the organization's internal release procedures defined in the Maintenance Organization Exposition.
The MOE.
Exactly, the MOE. So, if it's all happening within the same approved Part 145 organization, they maintain it, they install it on their own aircraft. They might not need that separate EASA Form 1 for the component maintenance itself.
I see.
Provided their own MOE clearly spells out how they handle internal releases and maintain that traceability. It's about streamlining paperwork where appropriate.
Okay, that makes sense. Like for a big airline with its own shop.
Precisely. Think of a large airline with its own Part 145 maintenance approval. They overhaul, say, a landing gear component in their own approved shop.
Right.
Then they install that same component onto one of their own fleet aircraft. Their internal MOE procedures for releasing that component back into their system might be sufficient.
So they wouldn't need an external Form 1 sort of certifying it back to themselves.
Exactly. It avoids that potentially redundant step when it's all under one roof, one approved system.
That makes perfect sense, leveraging internal controls. So when we zoom out a bit, what does this initial setup tell us about the bigger picture of component traceability?
Well, it fundamentally underscores the principle of accountability. That's key.
Right.
Regardless of whether a component stays internal or goes external, its airworthiness status must always be meticulously documented and fully traceable.
Okay.
So this initial section really sets the stage. It draws a clear line. Here's the general rule needing 2 releases, often involving a Form 1, but here's a specific exception for internal use if your MOE procedures are robust.
But clear documentation is always paramount.
Always. That's the constant thread.
Okay, now let's pivot. Let's dive into the specific scenarios where issuing an EASA Form 1 becomes really relevant, especially for components that maybe have a, let's say, less straightforward history.
Right. This is covered by the next part of the AMC, which introduces a specific case. It says, in the case of the issue of EASA Form 1 for components in storage before Part 145 and Part 21 became effective and not released on an EASA Form 1 or equivalent, or removed serviceable from a serviceable aircraft, or an aircraft which has been withdrawn from service, the following applies.
Wow, okay. That covers quite a range. Legacy parts, parts from working aircraft, parts from retired ones.
Exactly. This is where it gets really interesting, because it provides a pathway for an appropriately rated Part 145 organization to bring these kinds of components back into the certified supply chain.
Ensuring they meet today's standards, even if they have an unusual history.
Precisely. It's about managing that history safely.
Okay, let's start with Clause 2.1. This outlines when an EASA Form 1 may be issued for these components. What are those specific conditions?
All right. Clause 2.1 says, an EASA Form 1 may be issued for an aircraft component which has been. And then it lists several scenarios.
Okay.
First, maintained before Part 145 became effective or manufactured before Part 21 became effective.
So older components predating the current regs.
Correct. Think of finding a spare part manufactured back in the 1990s, maybe in an old warehouse, before Part 21 was fully effective.
Right.
A Part 145 organization can assess it now, and if it meets current standards, they can issue a Form 1 to bring it into the system.
Okay, what's next?
Second scenario, used on an aircraft and removed in a serviceable condition. Examples include leased and loaned aircraft components.
Ah, so parts coming off working aircraft but without a defect?
Exactly. An airline leases a plane for a year. At the end, certain components, maybe an APU, are removed. They're in good condition.
Mm-hmm.
An appropriately rated Part 145 org can then assess and release these with a Form 1.
Got it. What else falls under 2.1?
Third, removed from aircraft which have been withdrawn from service or from aircraft which have been involved in abnormal occurrences, such as accidents, incidents, heavy landings, or lightning strikes.
Okay, this sounds critical. Components from retired planes or ones that went through stressful events?
Very critical. This requires really thorough evaluation. For example, an aircraft is retired, taken apart for spares. A wing component is removed.
Right.
Even though the plane's retired, if that component passes a rigorous check, it can get a Form 1. Same logic applies after, say, a hard landing cess. The landing gear parts need special assessment.
And the last scenario under 2.1?
And finally, perhaps surprisingly, maintained by an unapproved organization.
Maintained by an unapproved organization. How does that work?
Well, it's a very specific allowance. It means components maintained by entities not operating under EASA Part 145 approval might potentially enter the certified system.
Okay.
But, and this is a big but, it comes with significant scrutiny and due diligence by the Part 145 organization issuing the Form 1.
Can you give an example?
Maybe a component from a military aircraft. It might have been maintained by military personnel operating under different rules, not Part 145.
I see.
If that part later needs to be used in civil aviation, this clause provides a potential pathway, but it's a high bar to clear regarding verification.
That covers a really wide range then. Old parts, used parts, parts from retired or incident aircraft, even parts without standard certification history.
It does.
So what's the Part 145 organization's specific role and responsibility in all this? Clause 2.2 addresses that.
Yes, 2.2 clarifies the responsibility, it says. An appropriately rated maintenance organization approved under Part 145 may issue an EASA Form 1 in accordance with procedures detailed in the exposition as approved by the competent authority.
So following their approved MOE procedures.
Crucially, yes.
Yeah.
And then it adds, the appropriately rated organization is responsible for ensuring that all reasonable measures have been taken to ensure that only approved and serviceable aircraft components are issued in EASA Form 1 under this paragraph.
All reasonable measures. That sounds significant.
It is. It places the burden of proof squarely on the Part 145 organization. They have to be absolutely diligent. They need to follow their own approved MOE steps for verifying history, condition, compliance. This could mean, extensive testing, maybe a full overhaul, detailed analysis, whatever it takes. It's about trust and accountability.
And Clause 2.3 defines appropriately rated in this context. That seems key.
Yes, 2.3 provides that definition specifically for this AMC. It says, for the purposes of this AMC number 2 only, appropriately rated means an organization with an approval class rating for the type of component or for the product in which it may be installed.
So they need the right rating for the job.
Exactly. You need the specific certification like a C rating for components, or maybe a B rating for engines if it's an engine component, or an A rating for the aircraft type.
Right.
You can't certify, say, an engine part if your shop is only approved for avionics components. The rating has to match the component or the system it belongs to.
Like, certifying a helicopter rotor blade requires a C rating for rotors or an A rating for that helicopter type.
Precisely.
Okay, let's quickly summarize this section then. We've covered the 4 main types of components: old stock, used serviceable, from withdrawn incident aircraft, and from unapproved maintenance that might get an of the Part 145 organization to ensure airworthiness through all reasonable measures, and the absolute requirement for them to be appropriately rated.
Right. It's all about maintaining the integrity of the supply chain, ensuring only safe parts get through.
Okay, moving on. Clause 2.4 details what must be included on the EASA Form 1 itself for these special cases. Sam, where do they sign and what information is critical?
Right. 2.4 gets specific about the form itself. First sentence. An EASA Form 1 issued in accordance with this paragraph 2 should be issued by signing in Block 1.4b and stating inspected tested in Block 11.
Okay, Block 1.4b for the signature and inspected tested in Block 11. That clearly flags how serviceability was determined.
Exactly. It signals this isn't a standard production release or a routine maintenance release after scheduled work. It's based on specific inspection and testing under these paragraph 2 provisions.
Got it. And then Block 12, it sounds like that's where the main story goes.
It is. Block 12 is critical. It needs to specify several key things. First, 2.4.1, when the last maintenance was carried out and by whom.
Essential for traceability, like last overhauled June 15th, 2023 by XYZ Maintenance.
Perfect example. Then 2.4.2 for unused components. If the component is unused when the component was manufactured and by whom, with a cross-reference to any original documentation which should be included with the form.
So establishing its origin if it's new old stock. Manufactured August 2005 by ABC Corp. C, attached coffee C, something like that.
Exactly like that. You need to link it back to its beginning and include the proof.
Okay, what else for Block 12?
2.4.3. A list of all airworthiness directives, repairs, and modifications known to have been incorporated. If no airworthiness directives or repairs or modifications are known to be incorporated, then this should be so stated.
Critical for compliance. You need to know what ADs are done, what repairs exist.
Or explicitly state none known. No ambiguity allowed. For example, AD 2023-01-02 incorporated. Repair scheme XYZ-001 applied. No known modifications incorporated.
Very clear. And life-limited parts.
Yes, 2.4.4.
Yeah.
Detail of life used for life-limited parts and time-controlled components being any combination of fatigue, overhaul, or storage life.
Absolutely vital for safety. We got to know the remaining life in hours, cycles, or time since overhaul.
Or even storage life consumed. Things like life remaining. 1,500 flight hours, 500 cycles, time since last overhaul. 2 years.
Okay, and the last point for Block 12?
2.4.5. For any aircraft component having its own maintenance history record, reference to the particular maintenance history record as long as the record contains the details that would otherwise be required in Block 12.
So you can point to an external logbook.
Yes, but that record must contain all the required Block 12 details. And crucially, the maintenance history record and acceptance test report or statement, if applicable, should be attached to the EASA Form 1.
So you reference it, but you also have to attach it full traceability, like refer to maintenance history log number MHL-XYZ-789, test report 0001-2024 attached.
Precisely. You provide the full package.
That is an incredible amount of detail needed for Block 12. It really is like a condensed history book for that specific component. Ensures total traceability and compliance.
It does. And the goal really is to ensure anyone downstream handling this component has all the critical information right there. They need to confirm its airworthiness and its suitability for installation without any guesswork.
Which logically leads to the question, how do these requirements play out for specific types, like new versus used components?
Exactly.
Okay, let's summarize this part quickly. For these special EASA Form 1s under paragraph 2, sign in Block 1.4b, state inspected tested in Block 11.
Yeah.
And Block 12 needs comprehensive data. Maintenance history, manufacturing details for unused parts, age repair mod status, life limits, and references to attached supporting docs like history records or pest reports.
It's all about ensuring a complete, transparent airworthiness status for these non-standard components.
Right. Now, let's get into the real nitty-gritty. The detailed procedures for specific component types, starting with new or unused ones under Clause 2.5.
Okay, 2.5 addresses new or unused components. 2.5.1 starts by saying, any unused aircraft component in storage without an EASA Form 1 up to the effective date for Part 21 that was manufactured by an organization acceptable to the competent authority at that time may be issued with an EASA Form 1 by an appropriately rated maintenance organization approved under Part 145.
So, certifying old stock, new parts again, made before Part 21 by an acceptable manufacturer.
Correct. And the Form 1 must be issued according to procedures in the Part 145 org's MOE. Now, there's a very important note here, Note 1.
What does that say?
Note 1 clarifies. It should be understood that the release of a stored but unused aircraft component in accordance with this paragraph represents a maintenance release under Part 145 and not a production release under Part 21.
Ah, so it's maintenance certifying existing stock, not production trying to skip Part 21 rules for new builds.
Exactly. It's not a backdoor to bypass production rules. It continues. It is not intended to bypass the production release procedure agreed by the member state for parts and subassemblies intended for fitment on the manufacturer's own production line.
Got it. So what conditions need to be met under 2.5.1 to issue this Form 1?
Okay, there are three main conditions listed as A, B, and C. 2.5.1a says, an acceptance test report or statement should be available for all used and unused aircraft components that are subjected to acceptance testing after manufacturing or maintenance as appropriate.
So you need proof it worked when it was made or last maintained, like a factory test report for an unused sensor.
Precisely. Then B. The aircraft component should be inspected for compliance with the manufacturer's instructions and limitations for storage and condition, including any requirement for limited storage life, inhibitors, controlled climate, and special storage containers.
Checking how it was stored.
Yes, and its current condition, it adds. In addition, or in the absence of specific storage instructions, the aircraft component should be inspected for damage, corrosion, and leakage to ensure good condition.
So even if new, you inspect it thoroughly for degradation due to storage, like checking seals on a pump stored for 10 years.
Exactly. And finally, C. The storage life used of any storage life-limited parts should be established.
Right, because some parts have a shelf life, even if unused, like rubber parts or pyrotechnics. You need to know how much of that storage life is gone.
Correct. That has to be determined.
So what if you can't meet all those conditions? Say the storage history is unknown or there's no test report. Can it still be certified?
Yes, but it triggers a more involved process described in 2.5.2. It states, if it is not possible to establish satisfactory compliance with all applicable conditions specified in subparagraph 2.5.1 A to C inclusive,
Okay.
the aircraft component should be disassembled by an appropriately rated organization and subjected to a check for incorporated airworthiness directives, repairs, and modifications, and tested in accordance with the maintenance data to establish satisfactory condition.
So take it apart, inspect everything.
Yes, and crucially, and if relevant, all seals, lubricants, and life-limited parts should be replaced.
Basically treat it like it needs an overhaul because the history is uncertain.
Pretty much. Then, upon satisfactory completion after reassembly, an EASA Form 1 may be issued stating what was carried out and the reference of the maintenance data included.
So the Form 1 reflects the expensive work done to verify it, like if you found a part in a dusty warehouse with no papers.
Exactly. You'd have to dismantle it, check everything, replace perishables, test it fully, and document all that on the Form 1.
That's a very clear process for unused components. Now, let's turn to used aircraft components removed from a serviceable aircraft. Clause 2.6.1 deals with parts from member state registered aircraft.
Correct. 2.6.1 covers the common scenario of used parts coming from active aircraft registered within an EASA member state. It says, serviceable aircraft components removed from a member state registered aircraft may be issued with an EASA Form 1 by an appropriately rated organization subject to compliance with this subparagraph.
Okay, so what needs to be complied with? It lists several points from A to I.
Right. Let's go through them. A. The organization should ensure that the component was removed by an appropriately qualified person.
Makes sense. Ensure it wasn't damaged during removal.
B. The aircraft component may only be deemed serviceable if the last flight operation with the component fitted revealed no faults on that component-related system.
This is crucial. If it caused a snag on the last flight, it's not serviceable even if it looks okay.
Absolutely critical point. C. The aircraft component should be inspected for satisfactory condition, including in particular damage, corrosion, or leakage, and compliance with any additional maintenance data.
Standard visual and basic checks for condition.
Yes. D. The aircraft record should be researched for any unusual events that could affect the serviceability of the aircraft component, such as involvement in accidents, incidents, heavy landings, or lightning strikes.
Checking the aircraft's history for hidden stresses.
Exactly. And it emphasizes, under no circumstances may an EASA Form 1 be issued. if it is suspected that the aircraft's component has been subjected to extremes of stress, temperatures, or immersion, which could affect its operation.
A major safeguard against unseen damage.
Definitely.
Okay.
E, a maintenance history record should be available for all used serialized aircraft components.
Traceability for individual parts.
Okay. Compliance with known modifications and repairs should be established.
Verifying required changes or fixes were done.
D, the flight hour cycles landings, as applicable of any life-limited parts and time-controlled components, including time since overhaul, should be established.
Tracking the accumulated life and time towards limits.
Correct. Compliance with known applicable airworthiness directives should be established.
Ensuring all mandatory safety ADs are complied with.
And finally, subject to satisfactory compliance with this subparagraph 2.6.1, an EASA Form 1 may be issued and should contain the information as specified in paragraph 2.4, including the aircraft from which the aircraft component was removed.
So if all those checks, A through H, pass, you issue the Form 1, including the source aircraft details like removed serviceable from aircraft registration GABCD on date.
Precisely. That closes the loop on traceability for that component.
Okay, that's for member state aircraft. What about components from aircraft not registered in an EASA member state? 2.6.2 covers that, and it sounds stricter.
It is much stricter. 2.6.2 says, serviceable aircraft components removed from a non-member state registered aircraft may only be issued with an EASA Form 1 if the components are leased or loaned from the maintenance organization approved under Part 145, who retains control of the airworthiness status of the components.
Only if the Part 145 org itself owned or controlled the part while it was on the non-EASA aircraft.
Essentially, yes. The EASA Part 145 organization needs to have maintained airworthiness oversight, perhaps through a lease agreement where they manage the component's status. This prevents a situation where parts just arrive from aircraft operating entirely outside EASA's regulatory system without any prior control or known history managed by an EASA entity.
So an EASA org leases an engine to a non-EASA airline. When it comes back, they can certify parts from it because they controlled its status.
Exactly. But they couldn't just buy a random part off a non-EASA registered aircraft they had no prior connection with and issue a Form 1 under this specific clause.
That makes sense from a control perspective.
It does. If they do issue one under these limited conditions, it still needs all the info from paragraph 2.4, including the aircraft details.
Okay, let's synthesize this section on used parts. For new unused, it's about acceptance tests, storage checks, shelf life, or for disassembly if needed. For used parts from serviceable member state aircraft, it's a long checklist. Qualified removal, no last flight faults, condition inspection, history check for unusual events, ADIM mode repair compliance, life limits confirmed.
Right. Very thorough.
And for used parts from non-member state aircraft, it's highly restricted, generally only allowed if the certifying Part 145 org lease loaned the part and maintained airworthiness control.
Correct. The core message is meticulous verification tailored to the component's source and history.
Now, for some even more complex cases, starting with Clause 2.7, components from aircraft that have been withdrawn from service.
Right. Aircraft being dismantled for spares. 2.7 clarifies a few things here. First, point A states, aircraft withdrawn from service are sometimes dismantled for spares. This is considered to be a maintenance activity and should be accomplished under the control of an organization approved under Part 145, employing procedures approved by the competent authority.
So taking planes apart for spares isn't just salvage, it's regulated maintenance under Part 145 control.
Exactly. It needs proper procedures. Then B says these components can get a Form 1 after a satisfactory assessment by an appropriately rated organization.
And what does that assessment involve? Point C.
Yes, C states, as a minimum, the assessment will need to satisfy the standards set out in paragraphs 2.5 and 2.6 as appropriate.
So it needs to meet the criteria for both new unused and used serviceable parts we just discussed. That's comprehensive.
It is. Plus, it adds, this should, where known, include the possible need for the alignment of scheduled maintenance that may be necessary to comply with the maintenance program applicable to the aircraft on which the component is to be installed.
Aligning maintenance schedules. Interesting point.
Very practical.
Yeah.
Then D emphasizes that removal and storage must meet Part 145 standards, even if the source aircraft had no current airworthiness certificate.
Okay.
Point E requires a structured plan for disassembly, carried out by a rated org under certifying staff supervision, ensuring parts are removed and documented correctly.
Planning and oversight are key.
Absolutely. Mandates reviewing all recorded aircraft defects and considering their potential effects on removed components.
Checking the aircraft's logbook for issues that might affect the part.
Critical step. G requires dedicated control documentation during disassembly, tracking removals, quarantining unserviceable parts, and recording any maintenance done.
Rigorous documentation.
And finally, stresses using suitable Part 145 facilities with proper environmental controls, tooling, and storage, especially for subsequent disassembly or storage after removal.
So a very controlled, documented, and assessed process for parts from retired aircraft.
Extremely. It ensures these parts are truly fit for service, despite coming from a non-flying aircraft.
Okay, next complex case. Clause 2.8, components maintained by non-Part 145 organizations. We touched on this earlier, but this elaborates.
Yes, 2.8 reiterates the need for extreme caution. It says, due care should be taken before acceptance of such components. In such cases, an appropriately rated maintenance organization approved under Part 145 should establish satisfactory conditions by.
And how do they establish that?
It lists 4 steps. A, dismantling the component for sufficient inspection in accordance with the appropriate maintenance data.
So often a full teardown is needed.
Often, yes. B, replacing all life-limited parts and time-controlled components when no satisfactory evidence of life used is available and/or the components are in an unsatisfactory condition.
Replace time-sensitive stuff if history is unknown or condition is bad.
Correct. Assume the worst if you can't prove otherwise. C, reassembling and testing as necessary the component.
Full functional check after putting it back together.
And D, completing all certification requirements as specified in 145.A.50.
So ultimately, it has to meet all the standard certification rules, despite its origins.
Yes, the Part 145 org takes full responsibility for bringing it up to standard.
And finally, the most critical case, components from aircraft involved in accidents or incidents, Clause 2.9.
This is handled with the highest level of rigor. 2.9 states, such components should only be issued with an EASA Form 1 when processed in accordance with paragraph 2.7.
So following the withdrawn aircraft process as a baseline.
Yes, and adding. And a specific work order, including all additional necessary tests and inspections deemed necessary by the accident or incident.
A tailored work order based on the event.
Exactly. And importantly, such a work order may require input from the TC holder or the declarant of a declaration of design compliance or original manufacturer as appropriate.
Getting the manufacturer involved due to potential unseen damage.
Highly likely, yes.
Yeah.
And finally, this work order should be referenced in Block 12.
So Block 12 points directly to the specific checks done because of the accident, like needing special NDT after a hard landing specified by the manufacturer.
Precisely that kind of scenario.
Okay, let's quickly summarize these really complex cases. Components from withdrawn aircraft are handled as a controlled maintenance activity under Part 145, involving structured disassembly, assessment against 2.5 and 2.6 standards, and careful documentation.
Right.
Components from unapproved organizations require extreme caution, usually involving dismantling, replacing life-limited parts if history is unknown, and full testing to meet all 145 Tech A50 requirements. And components from accident incident aircraft follow the withdrawn aircraft process PLUS, a specific work order with extra tests, potentially involving the manufacturer, referenced on the Form 1.
Correct. These processes are all designed to ensure safety, even when dealing with components that have complex, uncertain, or potentially compromised histories.
That was an incredibly detailed deep dive into the nuances of EASA Form 1 certification for all these different component scenarios.
It really covers a lot of ground.
It's clear that while the regulations are, quite strict and detailed, they're fundamentally designed to ensure safety and traceability at every single step. Doesn't matter where a component originates from.
And what's fascinating, I think, is how these rules build such a robust framework. You see how every detail matters: who removed the part, how it was stored, any accident history. It all plays a vital role in determining airworthiness. It really underscores that trust in aviation, it comes from meticulous adherence to these kinds of guidelines.
So what does this all mean for you, our listener? Well, it means that understanding these specific scenarios for EASA Form 1 issuance is critical.
Yeah.
Whether you're actually handling parts on the shop floor, maybe planning maintenance, or just seeking to be well-informed about aviation safety standards, this knowledge is key.
And thinking about all this complexity, it raises an interesting question for the future, doesn't it?
Oh, what's that?
Well, considering the complexity of tracking these histories, especially for parts from withdrawn aircraft or incidents, how might advancements in, say, digital traceability, maybe even blockchain technology, How might they further enhance the trust and efficiency of component certification, particularly for these components with non-linear or difficult histories?
That's a really interesting thought. Using technology to potentially simplify and strengthen this complex web of traceability. Definitely something to ponder. Looking forward to it. And don't forget, you can follow us on social media under the name Phoenix Way Academy. Thanks for listening. Stay safe.